So hello everyone. So in this video, we are going to show, we are going to see that how to cross-check the assumptions for the regression analysis or even for the linear regression analysis. So we assume in linear regression analysis, we assume that we are going to see the three main assumptions. We can say that first one is the linearity, whether the response variable and regressor variable have a linear relation or not. Second one is the normality, that the errors are normally distributed or not. And third one is the variance are constant or not. So to check those assumptions through R, what we are going to see here, look at the question. So here, as you can see here is a question that plot the scatter diagram. Does it seems like a straight line model and will be adequate? So here is the one question we have given as the temperature and viscosity. So obviously the temperature is depend on the viscosity, and we want, these are only the one regressor model, and we want to check whether this model is adequate or not. And for model adequacy, firstly we need to check what is the whether the model satisfy the conditions or assumptions of the model is not. So that we are going to see. So we are going to check the three assumptions: the normality, linearity, and constant variance. So to check first the linearity assumptions. So in R, firstly we added the data, that is our temperature and the viscosity. Now we'll just okay, now temperature will be our Y response variable. So we just rename our data, and our regressor variable, that is our independent variable, is the viscosity. Okay. Now we want to check the three assumptions. The assumptions are linear. Second one is the normality, and the third is the constant variance. Okay, that we are going to check. So for the linearity assumptions, whether these two variables have a linear relation or not, for that we are going to plot the scatter diagram. And to do that, firstly we need to fit the model. Okay, so fit is equal to lm, our y variable. Next, this is the simple regression command that we use. Okay, now plot. We want to see this through the scatter plot, whether our variables have a linear relations or not. So we have mentioned x and y. Now to modify it, x lab is equal to, we can write down what name we want on the x axis that we can add. So we want viscosity, so we can write it down here, viscosity, or to make it more specific, we can write down its measure. Okay, and then on y-axis, the label we want is the temperature. And so you can see here, there's a plot, and we want to check the whether they have linear relation or not. So AB line, so you can see here in this graph, the observations are not on line. So that means we can see that they have a very strong linear relation or what. What we want, if they has some linear relation, then all points should be on the line. But here we can see that the only not even one point is on the line. So that means there is a no linear relationship, we can say, or maybe it has some relationship, but we want to do some transformation to get a proper linear relationship. Okay. Now the next we want to find out the normality, whether the residuals are normally distributed or not. So for that, we need the residual. So the command to get the residual is this, and the residuals you can see here. Now we want to plot normal plot for this. So this is the residual normal plot or a QQ plot, but we want a line here just to understand. So you can see here again the observations are not on line. So this means the errors are not normally distributed. So the second assumptions are also not satisfied. This data, this variable also do not satisfy these two assumptions. Now the third assumption is the constant variance. And to check the constant variance, we'll just plot another graph, and that is plot fitted fit into residual. Oh. And we want a line here. So you can see here that through graph we can talk about whether these errors have a constant variable or not, variance or not. So you can see here these residuals or these errors are forming some sort of curve here, which is not. See, when we say that there's a constant variance, when there's a no any pattern that observations form, that means we want those residuals are randomly uh, allocated. And a second thing, we want them into one band, but here you can see that they are forming one pattern. So through this we can see that the constant variance assumptions also not satisfied. So that is our three assumptions that we was checking are not satisfied our model. So we'll do some transformation so that this model will follow these assumptions. But before going to that, we want to check what we have studied in this, that if we given any linear observation or we are performing linear regression or any non-linear regression or regression, okay, so we are performing any regression, we want to check in model adequacy that whether the assumptions for the regression analysis are satisfied or not, that our model or our variables satisfy those models or not. If those, suppose for the linear regression analysis, we have these three assumptions like linearity, normality, and the constant variance. If these three assumptions are not satisfied, that means we don't need to use linear regression here. We need to use the another regression, that is non-linear regression or many other regression we need to use here. So before performing any regression analysis, always check these assumptions. If you are performing or if you're applying linear or multilinear regression on any data, so always remember to check these assumptions. If your data is not following this assumption, then if still you apply the regression analysis, and whatever answers you get, these are really didn't mean anything. These are just the time waste. So so in your colleges, if you're in your projects and in your research papers, if you're applying regression analysis, then always cross-check your assumptions and check whether your data is following those assumptions or not. So this is for today. In upcoming videos, we will see what are the transformations and what are the other things we can do. If our data is non-normal, then what regression analysis we need to do, or what transformations we need to do to make it normal. So all this we're going to see in upcoming videos. Thank you.